Today we are going to discuss about the reflection of light. Reflection of light at curved surfaces. So today's topic is about what is pole, which one we call as center of curved surface. These basic things we are going to discuss today. If the surface is in the form of curve, not in the form of plane, in the form of some small bending structure, that is we call as curved surface. So generally here this one we call as plane surface. Okay, so if like this it bent, then this is called as curved surface. So this much of curve we do not observe in our mirrors. So look like those are plain mirrors, but they contains a small curved surface like this. In daily life what we are using curved surface mirrors, those are not contains much bending nature. Okay, so even though if they bent in the form of small, that is also we call as curved surface mirrors. So these curved surface mirrors are two types: concave mirrors and convex mirrors. If inside bent, if it is inside bent like this is called as concave mirror. So obviously this one we call as convex. If like this bent, convex. If it bent like this, concave. When another surface, if it is completely shaded or painted with any other substance, like generally we use different materials, means here it is not possible to pass the light through it from one surface to another surface. That one we discuss later. Means if projected light always comes back side, same side, that is we are calling as reflection, you know very well. So to happening reflection, here we are covering another surface, so that this one is not behaving like a refractive medium. About refraction we discuss later. Completely it behaves like a reflective medium, reflective surface. So if it is inside bent like this, backside completely shaded or painted, that is called as concave mirror. If inside completely shaded, backside contains reflective surface, then that is called as convex. This side you observe. Okay. We discuss later about concave, convex, but we are going to discuss about what is basic things. Pole. So this curved surface is like this. The midpoint of this curved surface is called as pole. The geometrical midpoint of this curved surface. Midpoint generally, this is the first end and this one is the second end. What is this one is midpoint. Okay, which is equal distance from top and bottom. That midpoint is called as pole. Midpoint of the curved surface is called as pole or the geometrical midpoint. Geometrical midpoint means your curved surfaces are not in the form of simple, some are in the form of different geometrical structures like rectangle, like square. Geometrical midpoint, middle geometrical midpoint is called as, we are calling as pole. From this curved surface you draw the perpendicular lines to this geometrical. For example, to this one is simple in the form of straight. this is a perpendicular line to this structure. These all perpendiculars are parallel to earth, parallel to means these all are geometrical, all are horizontal. But if it is not in the form of straight, if it is in the form of curved structure, these all perpendicular lines, they intersect at one point. The perpendicular lines of this curved surface, they intersect at one point. These perpendicular lines we call as normals. At which point all these normals are intersecting, that point is called as center of curved surface or center of curvature. We denote it by C. And that distance from this pole to center of curved surface, pole to center, not from center to pole. Look like both are similar, but we always measure the distances from pole. That is the rule, that is the sign convention rule. So the distance from pole of the curved surface to center of curved surface is called as what we call center of curved surface, radius of curved surface. Here we denote it with capital R. Radius generally we denote it with R, but here we are denoting it with capital R. And one another important thing, to this curved surface, if light rays are coming from long distant object, the light rays which are coming from long distance or distant object, those all are parallel to this geometrical structure of this principal axis. Sorry, I forgot to explain about principal axis. The principal axis is nothing but the line which is joining this pole and center of curved surface is called as principal axis. The line which is joining this pole and center of curved surface, that imaginary line here we call as principal axis. So if any light ray is coming from long distance object, those all are parallel to this principal axis. So after the projecting on this curved surface, what happens? They reflect. Because this is a reflected surface, outside completely we shaded it. So our light is not passing through this, it is coming back. So because of reflection, these all intersect at one point on principal axis. That point where those all reflected light rays are intersecting on principal axis, that point is called as focus. Generally this focus is in between center of curved surface and pole. Exactly it is in middle. So again the distance from pole to focus is called as focal length. This focal length is we are denoting with small f. The distance from pole to focus is called as focal length. What is the relation between focal length and radius? I said already, it is in middle. The focus is in middle, in between pole and center. I said already. So the focal length is half of the radius. The value of focal length is half of the radius. For example, if radius is 20 centimeters, focal length is 10 centimeters. If radius is 50 centimeters, focal length is 25 centimeters. If focal length is 15 centimeters, radius is 30 centimeters. That is the relation. F is equal to R by 2, half of the radius. Or R is equal to 2F. Radius is equal to double to the focal length. Okay, this is about basic things of center of curved surface, principal axis, pole, focus, focal length. We will meet in another class.